So let's spend some time talking about roots of real numbers. Now, before we get into the actual lesson itself, something we need to talk about are some of the parts of a radical. Now, most of us are just used to square roots, but there are other different types of roots. There's cube roots, fourth roots, fifth roots. There's an infinite amount of roots. And a couple little definitions, I guess, are any object or item or term that we have inside a radical is called the radicand. And the little number that's kind of stuck up here in this little crook right here, that's what we call the index. Now, if there's a radical that doesn't have one of those, then we just assume that that number is a 2, making it a square root. Like, for instance, this example right here. If I'm going to simplify this, it doesn't say 2 here, but it's assumed that there's a little 2 right there. And so we're looking for the square root of 169 x to the 4th. So the square root of 169 is 13. And the square root of x to the 4th is x squared. Now, how do I know it's x squared? Because remember, a square root is something that when you multiply it by itself, you get back to the original. So x squared times x squared is x to the 4th. Okay, so let's try another one. Here's another one that's a square root. Now, square root of 125. Now, there isn't an even square root of 125, so we're going to have to do a little bit of work here. So let's come up with some factors of 125. Well, let's see. The factors that I can think of would be 5 and 25. And so now, as I look at this, I can take the square root of 25. The square root of 25 is 5, so I'm going to bring this negative down. And then when I talk about the square root of a to the 12th, the square root of a to the 12th is a to the 6th. Okay, so what do I have left? Well, there's just a 5 left over. So the answer is negative 5 a to the 6th root 5. Now, what if it's a different number? What if it's like a number like a 3? So this would be a cube root. So if you were with square roots looking for numbers or factors that when you multiply them by themselves, you get back to the original. A cube root, you're looking for a number or a variable that when you multiply it by itself 3 times, you get back to the original. So in this case, I'm talking about the cube root of m to the 3rd. Well, the cube root of m to the 3rd is just m. And the cube root of n to the 7th, I would say that there isn't one that's even, but I would do n squared cube root n. That's what I would do. Now, kind of well, actually, let's back up a little bit. Let's talk about why that is. Remember, n to the 7th is n squared times n. Okay, there's 2, 4, 6, 7 n's right there. So the cube root of n to the 7th, notice how there's 3 of them here, would be n squared. There'd be 1 left over. Now, kind of a helpful hint or an easy trick, whenever you're taking a root of a variable, easy way to do it is just simply divide the index by the exponent. So for instance, 3 goes into 3 once evenly, so the cube root of m to the 3rd is m to the 1st. 3 and 7. 3 divides into 7 twice, but then there's 1 left over, so that's why there's an n left over right here. So that's a nice, easy trick there. The other thing is you have to remember that if it's a cube root or anything beyond a square root, you have to write the little index every time. Okay, so let's look down here. So this time it's a 4th root of 243 x to the 5th y to the 19th. Well, there isn't an even 4th root of 243, so let's break that down a little bit. Some factors of 243 are 81 and 3. So now the 4th root of 81 is 3, because 3 times 3 times 3 times 3 is 81. Okay, so let's use that little trick I just talked about up here. 4 divides into 5 or not evenly, but divides into 5 once, so it's x to the 1st. Okay. And there's going to be 1 x left over, sorry. And then 4 divides into 19 4 times, but there'll be 3 left over. Okay, now the only thing we're missing is this 3. I didn't put that in there. Okay, so the 4th root of 81 is 3. 3 left over. 4th root of x to the 5th is x to the 1st with 1 left over. 4th root of x to the 19th is 4 with 3 left over. And there you go. 3xy to the 4th. 4th root, 3xy to the 3rd. Okay? Pretty straightforward right there. Now, one thing I do want to talk about is there's a rule out there that sometimes people just kind of skip over, but it does occur if we're looking to be exact in our solutions. And this rule is called the even, even, odd rule. And the even, even, odd rule says that when I take an even root of a number or of a variable especially with an even exponent, so an even root of an even exponent, and my answer is an odd exponent, I have to use absolute value. Okay, so for instance, this is a square root. Okay, so this is my first even. If this is even, and if this is even. Okay, so even, even. And the square root of x to the squared is x to the 1st. And this is odd. Then you have to put your answer in absolute value. So the answer of the square root of x squared is absolute value of x. If this is even, and this is odd, you need to use absolute value. Okay? Let's try again. Let's try another one. So again, this is even, and this is even. So what's the square root of negative 2 to the 10th power? Well, that would be negative 2 to the 5th power. Even, even, odd. So I should put absolute value around it. So what does that mean? So what does this equal? Well, let's see. 2 to the 5th. Let's see. 2 squared is 4, 8, 16, 32. So that would be negative 32. So the answer is positive 32. Makes sense so far? Hopefully. Okay, so let's try another one. Okay, what about this one? The 4th root of 16 times the quantity of x plus 3 to the 12th. All right, well, the 4th root of 16. The 4th root of 16 is 2. And then the 4th root of x plus 3 to the 12th would be x plus 3 to the 3rd. Okay? Now, notice even, even, odd. So this has to be absolute value. Okay, last but not least, let's take a look at this one. Okay, as I look at this one, okay, it doesn't look like you can do a whole lot, but what I notice is that this inside part can factor. I could factor to be x plus 2 times x plus 2, which is also known as the quantity of x plus 2 squared. So can I square root that? Sure can. And I would get the square root of the quantity of x plus 2 squared is x plus 2. But this is even, because that's 2. This is even. And this is all to the 1st power, so it has to be absolute value. And that's the even, even, odd rule.